we go, guys. So we are on 3E.1 variations. We're gonna first start off by defining our vocabulary. So ignore that it says 3.5a. Ignore that. That was what it was called last year. I renumbered this year. But first up, we have 4 vocabulary words: combined variation, constant variation, inverse variation, and joint variation. Okay. When you have equations of the form x times y equals k, that is called an inverse variation. Okay. Next, when one quantity varies with respect to 2 or more quantities, we're going to call that a joint variation. Okay, so that's going to be our joint variation. And then when one quantity varies directly with 2 or more quantities, that's going to be called a combined variation. The key difference here is with respect and varies directly. Bye. All right, the product of 2 variables in an inverse variation is called the constant of variation. That's going to be our k value. Going to be our k value. All right, so how do we decide whether a relationship between 2 variables is direct variation, inverse variation, or neither? We do this by looking at our flowchart here. So the first thing you're going to do is ask yourself, are your x values increasing or decreasing? Okay, so after you decide whether it's increasing or decreasing, you're then going to go to the next question, which is, what are your y values doing? How are your y values changing? Are they increasing or decreasing? And then once you make that decision, it's going to lead you to your next. So let's say our x's and our y's are both increasing. That means that we have a direct variation situation. Okay, so what that means is that there is a constant of variation that equals our y values divided by our x values. Okay, that's our constant of variation. It means I would take my dependent and divide it by my independent, and for all of the values in that domain, that k value will be the same. All right, now this is the k value, but in terms of an equation, I would need to multiply by x to get y by itself. So you end up with y equals k times x. You should have worked with direct variations a lot in Algebra 1. You just talked about k as if it was just a constant rate of change, correct? All right, now let's go look on the other end. That's our inverse variation. Our inverse variation is x times y equals k. If I was to get y by itself here, it's going to equal what? K divided by x. Because in order to move our x, we would have to divide. Okay, and that would be the equation model for that. So we have our variation model, and then we have our equation. Now, in order for this to be true, your k value has to be the same for all of your y values. If it's the same for all of y values, then it's a yes. If it's not, then it's a no variation. Okay. All right. The best way to look at this is through an example. So we're going to go ahead and dive into our example. So on our first example, we have our x and our y. Step 1 is to determine, are your x's and y's increasing or decreasing? So on the first one, x's are increasing and y's are decreasing. So looking at my flow chart, if my x's are increasing and my y's are decreasing, which way do I end up on the flow chart? Do I go? We go to the right side, right? I'm increasing, then I'm decreasing, which sends me to the right side. So it's going to be an inverse variation. So we're going to be testing for inverse variation. So we're testing for inverse variation. In order to test for inverse variation, that means our K value, our constant of variation, is X times Y. So that means for when I multiply all of my X's and Y's together, they should get the same value. So 1 times 20 is 20. 2 times 10 is 20. 4 times 5 is 20. 4 times 5 is 5 times 4 is 20. Are they all the same? Yes. So therefore, it's inverse variation with the constant of variation of 20. How do you feel? Are you ready to follow those steps yourself? All right, so try example 2. If you finish example 2 faster than we do as a class, then go ahead and do example 3. So analyze your X and your Y, then decide which test are you going to do. I'm trying to figure it out. Because I want to learn and I shared it with you. Let me know if you need me. Check with your table mates. All right, so our X's were increasing and our Y's were increasing. So you should have been doing a direct variation, which is that your K equals Y divided by X. So you're gonna check to see if you divide your Y's by your X's, do they get the same value? 10 divided by 5 is 2. 20 divided by 10 is 2. 30 divided by 15 is 2. And 40 divided by 20 is 2. Did I get the same value for each one? Yeah. Yes. So my constant of variation is 2, and this is a direct variation. Okay? So do we see the difference between an inverse variation and a direct variation? Yes. Yes. All right. Try number 3. So example 3. See if you can do a little quicker.
So the first one you said the X is decreasing in the next one.
I didn't say X. I wrote X is increasing up to I next to my X.
Oh, okay. Sorry. Yep.
Once you understand what it does in fasting. Surprise! Crazy.
It's like so confusing. It's so easy.
Huh?
It's easy now.
Ah. All right, let's check ourselves. Example 3, you should have increase and a decrease, which makes it a inverse variation. So your K is going to equal X times Y. So I'm checking that it works for all of them. Does it work for everybody? Yes. So it checks out that this is an inverse variation. And K equals 12. Yes? Easy peasy. All right. So that's from a table. Do we only have tables when it comes to math? No, we have word problems, and we tend to mess up when we get to the word problems, right? Don't worry, we got it today. Okay. So when you're writing the variation equation to solve problems involving inverse variation, you need to solve for the constant of variation K before you can find an answer. So the first thing you're going to look for is your K. We're looking at inverse variation problems. And because of that, we're looking for when does K equals X times Y. Okay. Direct variation problems are in your, what's that class called? Algebra 1. Inverse variation is we focus more on in Algebra 2, because that's going to lead us to our reciprocal / rational function. Okay. All right, here we go. So the time t that is necessary to complete a task varies inversely as the number of people P working. If it takes 4 hours for 12 people to paint the exterior of a house, how long does it take for 3 people to do the same job? Okay, so your T inversely with your P. That means your K equals your T times your P. Does that make sense? So we're gonna find our K value. Do they give us enough information to find our K value?
Yes.
Yes. What do they tell us to find our K value?
4 hours.
4 hours and 12 people. So when T equals 4, it takes 12 people. What was that?
That's our lunch trip.
So our K value equals 48. Okay, so step 1, we read and mark the text. Step 2, we're gonna find our K value. So we found our K value. Now, step 3 is to answer the question. It says, if you have one less person doing the job, how long is it gonna take? Well, we know our K value, and we know how many people we have. How do I solve for T? Divide. So how long is it gonna take if I'm short one person? It takes 16 hours. So it's gonna take me 16 hours to do the job instead of 12 hours. So one less person is gonna take us 4 extra hours to complete the job. You can see how that's usable math, right? All right, guess who's gonna do example number 5? You are. You're so smart. What's going on? Okay, I'm right here. What happened? Okay. Step 2, is we're gonna look for our main value. How long?
Damn, 7. That's 10.
So, 3 people do it now.
10 people. Do we still divide it? By 10? 35.
I don't know.
It says-
We're trying to find T, so after the T right now. So your initial function is A equals P times T. Well, I know K and T.
Wait, 3.5?
All right,
Yeah.
trying,
Oh,
practice
5 hours.
example 5,
Then, sorry.
and then checking with each other. You want to know if you add extra men to complete a task, how much time is it going to take? How long is it going to take now? All right, so again, key thing here is it varies inversely, right? So we know that our K equals our T times our P, right? So they vary inversely with each other. And we have 5 and 7, so keeping that in mind, can you solve for your K? You should. Yes. Should and can. You do? Okay. Wasn't that, was it?
15. It's 15. Section alpha. Why is that?
You're writing, I look over, and there's nothing there.
Oh, yeah, it's fine, my bad.
Where is-
I did that.
You're exactly,
I know.
exactly, nothing there.
No, too bad.
Oh, he's working.
It's terrible.
No, he's not.
I don't know. Look at this. It's not bad. We really complain about the distance of the.
Yeah, but I saw mom, so.
It's still about 16.
All right, let's check ourselves. So your K should have equaled what? What's your K?
Oh,
You should have got 35 for your K. Okay, now you know your K value. You are looking for your T, and it says for 10 people. So I'm going to divide by 10. So your T would equal 3.5 hours. So if there's 10 people doing the job, they're now going to be able to save an hour and a half of time. Got it? Okay. All right. The time T needed to drive a certain distance varies inversely as the speed R. It takes 7.5 hours at 40 miles per hour to drive a certain distance. How long does it take to drive the same distance at 60 miles per hour? Go. Tell me how long. If I pick up my speed, is it going to take me?
No.
Good job. All right, guys, are we ready to check?
Yes.
So T varies inversely in the R. So you have K equal T times R, correct?
If your hand slips.
So that's gonna be 7.5 times 40, which is gonna give us 300. 300 equals T divided by 60, T times 60. So if you pick up your speed, it's now gonna take you 5 hours instead of 7.5 hours. Dun, 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 dun. Me personally, I have did math like this while driving to figure out, is it worth speeding or not?
is
You
it?
use math.
Is it, ma'am?
Yeah, this is it.
I'll be honest.
It's-
They're gonna, is the time I'm gonna save speeding worth it?
Yes.
Okay? And
Is it
then if
time
I do
versus
the math, I'm
money?
like, no, not really. All right, here we go. So it says the cost of each item bought is inversely proportional to the number of items spending a fixed amount. When 42 items are bought, each cost is $1.46. Find the number of items when each cost is $2.16. This is an example of bulk shopping. Does that make sense? How they say the more you buy, the more you save? Okay, that's what this is an example of. Or you can get more for your money, blah, blah, blah. So figure it out. How many items can I get if I am paying $2.16 instead of $1.46? Cool. So you can let your items be your X and your costs be your Y, right? X is my independent, cost is my dependent. So keeping that in mind.
Well, what are we down to?
Items, so it has to be both. When you're done, check with your neighbors to see if they got the same amount of items as you. Your neighbors not right.
You are, you're kind of slow today.
Did not know, did you?
It is double.
Oh,
digit.
I swear to
Better
God,
than your clothes.
Walked into class and was like, "Please, can you let me assign it to
He walks in, done. Done. He walks in, done. They have a lot of people. That should just come out.
Oh.
Huh?
For having his assignments done before these
He came and got it
classes
yesterday.
start.
Really?
Yeah, there you go.
Oh my.
He came and did it. He came and got it yesterday.
As I said, he walks into class and I'm like, oh, y'all aren't done with the assignment yet? The one for today? Yeah. Oh, bro, it's 2 minutes into class. What do you mean?
Get a multiply.
Peter Parker.
Yeah, I got it. We had a multiply.
Wants to get put by radioactive stuff. And then we did like that started. He said
Yeah.
it's the cancer.
That's off the little mental math, feel. Go.
And it always shows funny pictures of cancer kids coming.
Get over. All right, let's see how we did. So your K should equal X times Y in this case, so it'd be
Going so slow.
42 times $1.46. So what is 42 times $1.46? Anybody, everybody?
No. So it's getting low. $61.36.
So you should get 61 and some change, right? And some change. There you go. So it comes out to be 61, 32. And now you want to know, okay, 61.32 is my K, but now my cost is $2.16. How many items am I going to be able to purchase at that cost? Almost. Yeah, good job. All right, so 28 items. You should have gotten 28 items. Just FYI, you're close to the mic, so it's probably picking up everything you're saying versus. All right, let's talk about it from geometry. So going back to geometry, if I have the length L of a rectangle of a certain area varies inversely as its width. Okay, the length of a rectangle is 9 centimeters when the width is 6 centimeters. Determine the length of the width if the width is 8 centimeters. And I calculate that. Yes, we can. What's the first thing you need to do? Identify your independent and dependent from your text. Your length and your width. And then find your K value would be your second thing, right?
What are you asking? I'm working on.
Like a cartoon.
It's asking you what is the length if my
A
width is 8.
cartoon, you know how cartoons happen. Oh. This.
Are you trying to?
If they're pinching the problem. All right, check. Here we go. Let's see. So your K equals your 6 times your 9, which is 54. So 54 equals your length that you do not know times your width, which is 8. So we divide by 8 and we get 6.75 centimeters.
That's in.
6.75 centimeters. All right. Okay.